Hello everyone, welcome to my channel. This video is a complete tutorial on machine learning. In this video, we'll cover important topics such as regression, KNN, decision trees and many more. So without further ado, let's start our video. So what is machine learning? Machine learning, often called as ML, is a branch of an artificial intelligence that enables a system to learn autonomously from data and make decisions without being explicitly programmed to do so. The performance of machine learning model can be improved by providing large datasets and let the model figure out the patterns. Let's imagine how we teach a child to recognize a dog. We don't tell them proper rules to recognize a dog, but we show them many dogs and say this is a dog. Therefore, over time they learn how a dog looks like. So, machine learning works the same way. We train the machine by showing it with lots of examples and it learns how to make decisions based on that. Traditional programming versus machine learning. Now let's compare machine learning with traditional programming. In traditional programming, we write a set of predefined instructions and the computer follows those instructions in order to perform the task. Whereas in machine learning, we give set of examples, that is huge amount of data plus our expected outputs. And in machine learning, the computer learns the rule automatically and figure out how to accomplish the task. Therefore, machine learning is very versatile and powerful as it learns from the data and improves its performance continuously. So, why machine learning matters? As we know, there are lots of data these days and machine learning can handle this large set of data, analyze it and find a proper value as an output. Machine learning is also leading to the exciting innovations. It is the heart of many technologies we use today such as drones, VRs, robots and many more. It can contribute to business, finance, by fraud detection, detecting security threats, disease diagnosis and so on. Therefore, machine learning is at the heart of many technologies we use today. It helps machine to read like spam detection and machines to see such as object detection, face recognition. Similarly, it helps machine to decide on fraud detection, choosing recommendations, and it also helps to hear by choosing voice assistants such as Alexa or Siri. It helps machine to create by generating images, text, videos, and so many things. Therefore, machine learning is very important as it is transforming various industries in near future. Now, let's understand the basic flow of machine learning process. The step 1 is problem statement. In order to decide which category of machine learning models we use, at first we should have a deep understanding of our problems. The next step is data collection, where we collect all the data like emails, numbers, photos, and so on that is required for our models. And the next step is data processing. This step is very important part in the machine learning. It is like cleaning the data by correcting errors, scaling and removing duplicates and so on. The fourth step is to choose the right model. We should choose proper machine learning model for our clean data. Step 5 is to train the model. Once we decide machine learning model, the next step is to train the model. Training process is feeding the data to a learning algorithm. Once we train the model, the next step is to test the model and see how well it predicts a new and unseen data. The next step is to tune and optimize the model by using more data or better methods. The last step is deployment, where machine learning model is tested in production environment. Types of machine learning. Machine learning is divided into supervised learning, unsupervised learning, and reinforcement learning. Supervised learning. Supervised learning models learn from the label data. That means we provide input plus correct output. The goal here is to predict future output. Examples are object detection, spam detection, forecasting, and so on. Next we have is supervised learning algorithms. There are different algorithms in supervised learning like linear regression, logistic regression, decision trees, support vector machines or SVM, k-nearest neighbors KNN, random forest, naive algorithm. So we will discuss about supervised learning in our upcoming videos. Now let's move to the unsupervised learning. Unsupervised learning. Unsupervised learning models learn from on-level data. That means we only provide lots of input data and we do not give known output to the model. The goal here is to find structure in data and provide us the proper output. The examples are recommendation engines, anomaly detections, medical imaging, and so on. Next is unsupervised learning algorithms. We have hierarchical clustering, fuzzy means, k-means clustering, and so on. Reinforcement learning. In reinforcement learning, the model learns by doing and through various trials and errors. The examples are game AI like chess, robotics, self-driving cars, and so on. Now reinforcement learning is rapidly growing with huge potential and we will experience more groundbreaking innovations in near future. Applications of machine learning. Machine learning is almost everywhere now, like in self-driving cars, security, recommendation systems, customer service, voice assistance, fraud detection, digital marketing, search engines, and face recognition. Supervised learning. So let's get started. So what is supervised learning? Supervised learning is a type of machine learning where the model is trained using label data where each input has a corresponding correct output. Here, the label data means a dataset which contains lots of examples. As shown in the figure, we have animal database which contain different types of animals which are labeled and stored. And in supervised learning, the trained model learns to predict the output from the input by finding patterns or the structures in the data. Supervised learning example. This is the example of supervised machine learning algorithm. So here in input side, we have collection of raw data, that is large set of tigers, camels, horses, which are labeled according to their names. Then the algorithm is trained with this information. And the processing happens, so machine would find a way on its own to identify which one is tiger or camel or horse, and finally we'll get our expected output. So this is supervised machine learning and it is most commonly used method. Supervised learning process. Now let's walk through a basic supervised learning workflow. First is collect data. We perform data collection such as images, text, numbers, and so on. And the next is label the data, where we add correct labeling to our data, for example cat, dog if we are training for that. And another is split the data. Here we split the data into training dataset and testing datasets. And next we have is choosing a model. We have to choose a model such as logistic regression or decision tree or any other that is fit for our model. And the another is to train the model. Here the model is fed with the training data, so it learns the patterns and relationships between input data and the output data. Another is evaluate the model. We evaluate the model by using our test data to see performance of our model. And finally, use it. Once we find the model is accurate, then we use it for predictions on new data. Therefore, this is the basic flow of supervised machine learning. Now let's see the types of supervised learning. Types of supervised learning. There are two tasks of supervised learning. One is classification and the another is regression. Classification. In classification, the models learn to assign labels and the output is a categorical variable. The examples are emails are classified as spam or non-spam emails. Similarly, the model can classify an image into a dog image or a cat image. Linear classifiers support vector machines, decision trees, and random forests are the common types of classification algorithms. Regression. In regression, the model learns to estimate a value. Therefore, the output is a continuous variable. For example, regression models are useful for predicting house prices, forecasting sales, estimating temperature, and so on. Linear regression, logistic regression, and polynomial regression are some of the regression algorithms. Supervised learning applications. Supervised learning is everywhere. Therefore, let's look at some of the examples. It is applicable in stock predictions, like predicting stock prices based on past data. Fraud detection. Supervised learning is used for fraud detection on banking to identify whether the transaction is legitimate transaction or not. It is also used for medical diagnosis such as images labeled as cancerous or healthy. Another is spam detection. As I said earlier, emails can be labeled as spam or non-spam by the use of supervised learning. Next is voice assistant, such as recognizing sounds like play music or stop the music. Therefore, these are some of the practical examples of supervised machine learning. Supervised learning algorithms. Here are some commonly used algorithms in supervised learning. Decision trees. Decision tree is a type of supervised learning algorithm where flowchart-like models is used for decision making. Linear regression. Linear regression is a type of supervised learning regression algorithm that is for predicting numbers. Logistic regression. Logistic regression is a supervised learning classification algorithm which is used to predict binary classification. Random forest. Random forests are made up of a group of decision trees which work together to make predictions. K nearest neighbor, that is KNN, classifies based on the closest data points. Naive-Bayes algorithm. Naive-Bayes algorithm is a supervised learning algorithm based on Bayes' theorem. SVM or sport vector machines is great for separating two classes. Hence, we use these types of supervised learning algorithms according to the dataset and the problem we are solving. And I will definitely make detailed videos on each topics in my upcoming tutorials, so keep watching my channel. In today's video, we'll break down unsupervised learning in the simplest way possible. So let's get started. What is unsupervised learning? Unsupervised learning is a type of machine learning algorithm where the model learns from the unlabeled training datasets. This algorithm discovers hidden patterns, structures, and relationships within the data without any prior knowledge of the outcomes. That means the model has only input parameter as we don't provide output parameter to our model. So the model is basically learning without supervision. Let's see an example of unsupervised machine learning algorithm. So for input, we have collection of large set of tigers, camels, horses dataset, but these data are unlabeled. Then algorithm is trained with these raw datasets. In the interpretation stage, the model figure out how to organize raw datasets based on inherent patterns and structures. Then algorithm is all about choosing unsupervised learning algorithms such as clustering, anomaly detections or other in order to find the patterns in the data. After that, the processing happens where the algorithm is applied on the data and a machine would find which one is tiger, camel or horse. Then finally, as a result, we will get our expected output. Unsupervised learning process. Now let's discuss a basic unsupervised learning process. The first is collect data. At first, we collect raw data like text, numbers, images, and so on. Then pre-processing. We clean the raw and unlabeled data by handling missing values, removing repetitive data, normalizing, and so on. Then there is a model selection. We choose machine learning algorithms such as clustering. After that, we have model training. Here, the model is fed with the training data, so the algorithm finds the patterns or the structure in the data. And next is evaluation, where we evaluate the model to see its performance. And then finally, we use the model. Since there are no correct outputs to compare, we don't use accuracy like in supervised learning. So this is the basic flow of unsupervised machine learning. Now let's see the types of unsupervised learning. Types of unsupervised learning. There are three main types of unsupervised learning: clustering, association rule algorithm, dimensionality reduction. Now let's go and see each of them. Clustering. Clustering is grouping of unlabeled data into clusters based on their similarities or differences. The goal of clustering is to identify patterns or the structures in the data. The real-world examples are pattern recognition, image segmentation, customer segmentation, and so on. Association rule method. An association rule is a rule-based technique for discovering relationships between parameters in large dataset. They are used for market basket analysis. Market basket analysis is a data mining technique which is used for better understanding of customer purchasing patterns based on the relationship between different products. For example, the customer purchase patterns. Different shops use this algorithm to find the association among the sale of one product with respect to another product according to customers' behavior. For instance, if a customer buys shoes, then he or she may also buy socks or slippers or boots. It seemed like in Amazon's term that these customers who bought this item also bought. Dimensionality reduction. Dimensionality reduction is a technique used for reducing the number of features or dimensions in a dataset while also preserving the integrity of data as much as possible. This feature is used when the number of features in dataset is large, and this process is typically used in pre-processing stage. This process is performed because visualizing data in more than 3 dimensions is very difficult. If the dimension is reduced from high to low, then it also lowers the computational load and it increases the speed and efficiency. The example is like in visualizing high dimensional data or the data compression, image recognition, and so on. Unsupervised learning applications. The applications of unsupervised learning are in recommendation systems for various products and services, customer segmentation for personalized marketing, natural language processing to categorize articles, anomaly detection in cybersecurity and finance, computer vision for object recognition, medical imaging for image detection, segmentation, and so on, climate support for weather analysis, data compression, and feature extraction in deep learning. Therefore, these are some of the applications of unsupervised learning. Now let's move to the next chapter. Unsupervised learning algorithms. Now let's see some popular algorithms used in unsupervised learning. In clustering, we have k-means clustering, hierarchical clustering, density-based clustering, spectral clustering, Gaussian mixer models. In association rule method, we have a priori algorithm, eclat algorithm, FP growth algorithm, and in dimensionality reduction, we have principal component analysis, PCA, linear discriminant analysis, LDA, factor analysis, autoencoders, and so on. So these are some of the unsupervised learning algorithms, and each algorithm has different strength depending on the dataset and the goal. In today's video, we are learning about regression. So let's get this started. So what is regression? Regression is a supervised learning technique used to predict continuous numerical values based on one or more independent features. It helps to make better decisions by finding relationships between variables. There are two types of variables in regression. One is independent variable and the another is dependent variables. For example, regression can be used to predict a stock price, house price, and so on. It helps to answer questions like what will be the value of x given y. Types of regression. Now let's talk about the types of regression. The first is linear regression. It assumes a linear relationship between dependent and independent variables. The example is like predicting height from age, weight from age, and so on. The next is multiple linear regression. This is same as the linear regression but with multiple input variables. The example is like predicting the price of house based on multiple features like location, room size, and so on. The third is polynomial regression. It is used when there is non-linear relationship between variables. The example can be modeling growth curves in biology. Another is Ridge and lasso regression. These are regularized version of linear regression. They help avoid overfitting by adding penalties to the model. Support vector regression (SVR). SVR has same concept as support vector machines, but it is for predicting continuous values, and it tries to fit the best line within a margin of error, and it is good for high dimensional data. Decision tree regression. It uses a tree-like structures to make decisions. Random forest regression. It is an ensemble method which builds multiple decision trees and averages their predictions. It reduces overfitting and increases accuracy. Regression evaluation metrics. Here are some of the evaluation metrics for regression. Mean squared error (MSE). It is a squared difference between actual values and the predicted values. root mean square error RMSE. It is the square root of mean squared error. Mean absolute error MAE. It calculates the average absolute difference between predicted and the actual values. R squared core, coefficient of determination. It measures how much of the variance in the target variable is explained by the model. Higher values is better fit, ranging from 0 to 1. Regression workflow. Here's how a regression model works. The first is collect the data. Here we gather data, that is independent variables and dependent variables. The second is pre-process the data. We handle the missing values, normalize and split into train and the test data sets. And the third is train the model. We use an algorithm like linear regression to learn patterns in the training data. The fourth is make prediction. The model predicts new outputs based on unseen inputs. The last is evaluate the model. We evaluate the model to measure how accurate the predictions are. So this is the workflow of regression. The real-world applications of regression are in finance, such as predicting stock prices, interest rates, and so on. In energy, such as forecasting electricity demand. In business, such as inventory planning, sales and revenue forecasting. In healthcare, such as predicting patient result or recovery time. In agriculture, such as estimating crop production. Advantages. Let's see the advantages of regression so it will be easier to understand when to use it. The first is it is easy to understand and implement, so it is great for beginners. Fast and efficient. It is fast and efficient because regression models can train fast even on huge datasets. It works well for linearly related data. Disadvantages. Sensitive to outliers. They can be sensitive to outliers. Can underfit complex data. Simple regression models may miss patterns in complex datasets. That's why it can lead to low accuracy. Need attention in pre-processing. There needs an attention in pre-processing because regression is affected by missing values, non-normal data, and so on. Today we are going to learn about linear regression. So without further ado, let's start our video. So what is linear regression? Linear regression is a type of supervised machine learning algorithm where the model learns from the label data and identify patterns from those data to make predictions. And there is a linear relationship between input and output, which means if we give some input data, then it will try to predict an output number, such as in predicting the price of house. And it's like drawing a straight line through our data and finding the best possible relationship between the inputs and the outputs. Let's see an example. Suppose we are trying to predict a student's score based on number of hours they have studied. It is obvious that if a student study for more hours, then they will get better marks. Let me explain this. For example, I have some data like this. Here we have two variables. One is independent variable x, which is study hours, and the another is dependent variable y, that is score. So let's assume if the student study for 1 hour, they will score 54. And if they study for 2 hours, they will score 60. And if they study for 3 hours, they will score 66. And 4 hours, they will get 71. And if they study for 5 hours, they will get 79. So this is our data set. And if we plot this in graph, we will see like this. So see, here we get a straight line and the score changes at a constant rate as the input changes. That is, if students study for more hours, then they will get more score. Hence, this is what simple linear regression looks like. Linear regression applications. It is often used in predicting house prices. For example, linear regression helps us to create a model to predict the price of the house based on its size. Bigger the house, higher the prices. It is used in education to predict student performances. In finance, to predict stock prices. In marketing, for example, a company wants to know how much to spend on ads to increase sales. In that case, linear regression helps them to forecast sales for given ad spends. It can be used in agriculture. For example, farmers can use data such as temperature and rainfall to predict crop yields and so on. Therefore, these are some of the applications of linear regression as we are dealing with numeric and continuous values, which is exactly what linear regression is designed for. Mathematical expression. Mathematical expression or the best fit line for linear regression with one independent variable is given by y equals to mx plus b, where x is the input, that is independent variable, y is the predicted value, that is dependent variable, m is the slope of the line, that is how steep or how much y changes for a unit change in x, and b is the intercept, that is when line cuts y-axis or the value of the y when x equals to 0. The goal of linear regression is to find the best values for m and b that fit our data. Let's see the real example and calculate slope m and intercept b. So I am going to take the earlier data set. We have study hours as x, a dependent variable, and the another is scores, that is y, which is independent variable. Now let's calculate the mean of x. As shown in the table, we add all the values of x and divide by 5. Then we will get the mean of x. That is 1 plus 2 plus 3 plus 4 plus 5, and then divide by 5, and the result we get is 3. So this is our mean and we represent it as a x dash. Similarly, we calculate mean of y, and as shown in the table we get the value 66. Next step is to calculate the deviation of x, that is x dash, which is our mean value, minus x. Suppose 3 minus 1 equals to 2, 3 minus 2 equals to 1, and so on. Then we calculate the square of deviation of x, that is square of 2 is 4, 1 is 1, 0 is 0, minus 1 is 1, minus 2 is 4. And next step is to calculate deviation of y, that is y dash minus y. Then we calculate x dash minus x into y dash minus y, and as a result we get like 2 into 12, that is 24, 1 into 6, that is 6, and so on. And at last we calculate the sum of product of deviations, that is 24 plus 6 plus 0 plus 5 plus 26, that is equal to 61. So these are our calculations. The formula to calculate slope is m equals to sum of product of deviations divided by sum of square of deviations of x, that is 61 divided by 10 equals to 6.1. So this means if I change the value of x by 1 unit, then the value of y changes to 6.1. And the formula to calculate intercept b is b equals to mean of y minus slope into mean of x, that is 66 minus 6.1 into 3, that is equal to 66 minus 18.3, which is 47.7. Hence this is the value of b. The intercept b is the value of y when x equals to 0. That means in this example 47.7 could be the best score when a student studies for 0 hours. Now we want to know how much a student scores if he or she studies for 6 hours. We have our equation y equals to mx plus b, and here we have calculated all the values needed. So y equals to mx plus b, that is 6.1 into 6 plus 47.7 equals to 84.3. Therefore, if the student studies for 6 hours, he or she will score 84.3 marks. So this is the best case scenario. Let's see the example of linear regression in Python code. So first let's import our libraries. This is step 1, and then import numpy as np. NumPy is used to create data arrays and it is for numerical operations. Now let's import another. Import matplotlib.py plot as plt. So matplotlib.pyplot will help to visualize the data and the fitted line. Next we will sklearn linear model and then import linear regression. So we import linear regression, which is the regression model from scikit-learn. Next we are step 2. Let me do like this, and then Then step 2 is about creating dataset, right? And then we'll create the dataset of x and y, where x is the study hours. So has study hours, and then variable x equals to np arrays, and let's give our data, that is 1 2 3 4 5, and then close the parenthesis and dot reshape and -1, 1. So here x is the hours studied, which is our input, and this is independent variable. So this will receives the data into the column vector. Another we have is scores. So scores, and then y equals to np dot arrays, and then we have the marks is 54, 60, 66, 71, 79, and then so y is a scores obtained, which is the output, and this is a dependent variable. So this is our data set. Now let's create and train the linear regression model. That is step 3. Create and train the model. So model equals to linear regression, and then this. So we have created a linear regression model. Now we will train the model. Model dot fit x comma y. So this fit trains the model using the data. Next step is to make prediction. Let's say we want to predict the score for a student who have studied for 6 hours. Therefore, step 4 is like make a prediction. So score predicted equals to model dot predict, and then we want to predict for 6 hours. So predict 6 will provide the predicted score for a student who have studied for 6 hours. Now let's print the result. Print, and then score predicted for 6 hours of study, and then score underscore predicted, and then I will 0. Okay, now let's run this code. I got the error. sklearn dot linear. Oh, too many errors. Track np arrays 1 2 3 4 sep. Sorry, arrays. Okay, score predicted for 6 hours of study is 84.3. Now let's visualize our result. Therefore, step 5 would be, let me write here. Okay, hash step 5 equals to visualization, and then I'll plot scatter x comma y comma, and let's give color like blue, and then a label equals to actual data, and then close this. Another is plot x comma model dot predict x, and then color equals to red, and comma label equals to regression line. Okay, so here the scatter plots the actual data points and in blue color, whereas the plot draws the regression line predicted by the model in red color. And let's give x and y, like x label, then study hours, and then plot at y label equals to scores, and then plot title study hours versus scores, and then plot dot lesson, and then plot dot show. So labels and the titles are added for clarity, and so will display the plot. So let's run this. See, we get our result. So these blue dots are the actual data, and the red line represent the regression line, and we have predicted the scores for 6 hours is like 84.3. Advantages: very easy to implement, results are easy to interpret, great for small data sets, computationally fast. Disadvantages of linear regression: they are sensitive to outliers, they assume linearity, and it doesn't perform well on complex or non-linear data, and it can only predict numbers. Types of linear regression: simple linear regression. If there is only one independent variable, then it is known as simple linear regression. Multiple linear regression: when there are more than one variable, then it is known as multiple linear regression. So that's it for linear regression. We have learned what is linear regression, how it works, math behind it, and how to implement in Python, and its advantages and disadvantages. So if you found this video helpful, do not forget to like, share and subscribe my channel. Share it with your friends who are studying machine learning. Welcome back everyone. We are at day 6 of our machine learning series. In today's video, we are going to learn about polynomial regression. So let's get started. What is polynomial regression? Polynomial regression is an extension of linear regression where the relationship between the dependent variable and independent variable is modeled as nth degree polynomial. In many real-world scenarios, the relationship between variables is often non-linear. Polynomial regression helps us to model this kind of curved data points by adding higher degree power of x. Polynomial regression equation. The equation of linear regression is y equals to b0 plus b1x plus e, where x is the independent variable, y is the dependent variable, b0 and b1 are the coefficients, e is the error. Similarly, the equation of polynomial regression is y equals to b0 plus b1x plus b2x square plus b3x cube plus bn xn plus error, where x is the independent variable, y is the dependent variable, b0, b1 to bn are the coefficients of polynomial, n is the degree of the polynomial, and e is the error. Example. Let's consider an example of predicting house prices where we analyze the relationship between the price of the house and the size of the house. The relationship between these two factors might not be linear. So let's see this table. Here we have two parameters. One is house size and the other is house price. As shown in this table, we see from 20 square meter to 70 square meter, the price of the house increases very fast, whereas after 70, the price of the house slows down. Now let's plot this in graph. So this is our data. When we see these data points, we realize that a linear or the straight line won't fit well in this situation. Therefore, for this type of data, we need polynomial regression. Quadratic polynomial regression equation. Now let's apply polynomial regression to model the relationship between the size of the house and the price of the house. Suppose if we try a quadratic model, that is degree equals to 2, which include both linear and the quadratic terms for better fit. The quadratic polynomial regression equation is y equals to b0 plus b1x plus b2x square. So by using this polynomial regression equation, it allowed the curve to bend and fit the data better. In this way, it will capture the nonlinear progression of the house price and its size. Now let's implement this and see in the Python code. Now let's practice polynomial regression in Jupyter Notebook. So hash polynomial regression. At first we'll import libraries. So import libraries, import numpy as np. So numpy is used to create data arrays and it is for numerical operation. Another is import matplotlib.pyplot as plt. So matplotlib.pyplot will help to visualize the data and fit it line. Next is I will write from sklearn.linear model import linear regression. So in this case we will import linear regression, which is the regression model from scikit-learn. Another is from sklearn.preprocessing import polynomial features. So here we import polynomial features class from the sklearn preprocessing module in scikit-learn. The next step is to create the data set. So create data set. The one parameter we have is house price, right? House price, and then I will represent as x, and then np dot array, and I will give the data like 20, 30, 40, 50, 60, 70, 80, 90, and then close this parenthesis, and then I will reshape and -1, -1 and parenthesis. So x is the house size, which is our this is house size, Okay, so x is the house size, which is our input, and this is independent variable. And another is house price, that is y equals to np dot array, and then I will give the values like 155, 190, 220, 245, and then 260, and then 265, 270, and closing the parenthesis. So this is y, where we store our house prices. So these are the data, and this dot reshape -1, 1, this code will reshape the data into a column vector. The next step is to transform features into polynomial degrees, like transforming features into polynomial, and then the degree is, let's say, 2. So I will write poly equals to polynomial features, and then I will mention the degree equals to 2. So this line means we are creating a polynomial features object named poly. Degree equals to 2 means it is for quadratic, and it will use like 1, x, x square, and if it is 3, then it's for cubic model. So we will use like 1, x, x square, x cube. But if it is 1, then it is for linear. And the next line is x underscore poly equals to poly dot fit underscore transform, and then x. So this will transform input data into polynomial form. Next step is to train the model. So train the model. Model equals to linear regression, and then this. So this line will create a linear regression model object. Even though we are doing polynomial regression, we'll still use linear regression, because technically polynomial regression is equal to linear regression on polynomial features. And then another is, I will write model dot fit, and then I'll give x poly, and then y. So this fit means to train the model. Another step is to make prediction. So prediction y underscore prediction equals to model dot predict, and then x poly. So after training the model has learned the best equation for our data, and this dot predict is used to make prediction using that equation. Another step is to visualize. So has visualize. So plot dot scatter, and then x comma y comma, and then I will give color equals to blue, comma label equals to actual data, and then close the parenthesis. So this scatter plots the actual data points and in the blue dots, and another is plt dot plot, and then x comma y underscore red, and then color equals to red, and then label equals to polynomial regression. So this dot plot will draw the regression line predicted by the model in red, and then plot dot x label and equals to like house size and in square meter, a square meter, and then okay, this x label is for labeling x-axis, another is for labeling y-axis, y label, and this is like house price, and in $1,000, and okay, now let's do plt.legend and then plt.show. Okay, this show will display the plot. Now let's run this code and see what is the result. Here is error x underscore poly. Okay, this one poly dot fit underscore transform x. So here is the error, I think form. Yeah, so yeah, this is the result. See, we get the curved line, but if the degree of the polynomial is 1, let's see and run. See, we get the linear line, so it does not cover all of the data points. That's why we do the polynomial regression. Like this. Polynomial regression advantages: more flexible. That means it is more flexible than linear regression. Better fit. It is better fit as it can capture non-linear trends in the data. Polynomial regression disadvantages: complex. They are more complex and computationally expensive for high degree polynomials. Overfitting. High degree polynomials can bend too much and fit noise. Hello everyone, welcome back to my channel. In today's video, we are going to learn about logistic regression in machine learning. So without further ado, let's get started. So what is logistic regression? Logistic regression is a supervised machine learning algorithm that helps us to predict categorical outcomes such as yes or no. Logistic regression is not used for regression problems. Instead, it's used for classification problems. Example of logistic regression are: it helps us to predict categories such as whether an email is a spam or not, whether loan is approved or not, whether a student passes or fails. Therefore, logistic regression has output probabilities between 0 and 1 that are converted to either yes or no or 0 or 1. Equation. The logistic regression model uses the logistic function to predict the probability. First, let's see the linear equation. Linear equation is equals to z equals to b0 plus b1x, where x is the input variable, b0 is intercept, and b1 is the coefficient. So, to squeeze this z into a probability between 0 and 1, we use sigmoid function. Logistic regression equation. So this is the formula of the sigmoid function, where p is the probability of dependent variable, b0 is the intercept, b1 is the coefficients, e is the base of the natural logarithm, x is the independent variable. So if we plot this logistic regression equation, we will get an S curve. This is called sigmoid curve. You can see logistic regression function returns only values between 0 and 1 for the dependent variable. We divide into two categories, class 1 and class 2. 0.5 is the point to divide between two classes. Therefore, if P is greater than 0.5, then we predict it's class 1 or pass or S. Similarly, if P is less than 0.5, then we predict it's class 2, which means fail or no. Let's see an example of logistic regression. Suppose we decide the result of exam based on study hours. So here we have our data. Here input is hours studied and output is result, that is pass 1 or fail 0. As we see, the probability of passing is near 1 if students study for longer hours, whereas the probability of passing is near 0 if the student study for short hours. And around 3.5 or 4 hours, the probability crosses 0.5, and that is called decision boundary. Now let's practice logistic regression in Python code. Let's see how we can implement logistic regression in Python. First, let's import some libraries. So, has importing libraries. So import numpy as np. So numpy is used to create data arrays and it is for numerical operation. Another is import matplotlib dot pyplot as plt. So this is to visualize the data. From sklearn dot linear model import logistic regression. So this line will import logistic regression. Now let's create a data set. Therefore has data set and x equals to np.array, and then I will give 1, 2, 3, 4 and then 5, and dot reshape -1, 1 and then close the parenthesis. So here x is the hours study, which is our input, and this is independent variable, and another is y equals to np.array, and I will give 0, 0, 0, 0, 0, 1, 1, 1, and then this. So here y is where we store the results based on the study hours. Next is to create and train the model. Has creating and training the model. Mode equals to logistic regression and then so this line will create logistic regression model object. Then another is mode dot fit and then x comma y. The mode dot fit is where training happens, and after training the model knows more study hours has high chance of passing. Next step is to predict. Therefore has predicting let's say for 4 hours, so probability equals mode dot predict underscore proba, and then I will give 4. So this will get the probability for 4 hours. Another is to print like probability of passing for 4 hours of study, and then I will give probability 0 and then 1 close this parenthesis. So this probability 0 and 1, it gives the probability of class 1, that is pass. So this line will predict our result. Next step is visualization. So visualization, plt dot scatter, and then x comma y comma, and we'll give the color equals to blue, and comma we'll label, and let's say actual data, and then parenthesis. So this line plots the actual points and it is denoted by blue dots. Another is plt dot plot, and then x comma mode dot predict, and underscore proba, and x comma 1, okay, comma color equals to red, comma label equals to logistic curve. So this plot will draw the regression line predicted by the model, and it is denoted by the red line. Next is plot dot x label, and then study hours. So this is the representation for x-axis. Next is plot dot y label, and then pass probability. So this is to denote y-axis. And let's do plot dot legend and plot dot show. So this line will display the plot. Now let's run this code. Error here, plot mode dot fit xy. Okay, there is error. Let's fix this. Mode dot fit xy. I think this is right. Oh, I got this. This is 6. Let's run. Okay, next is, okay, for this error I think I forgot to give parenthesis. Okay, let's run and see. I'm sorry. So let's fix this. Let me do like this. Now let's run. So this is our result. The probability of passing for 4 hours of study is 0.63, that is equal to like 63%. So this is the example of logistic regression. Yeah, now let's move to the another chapter. Types of logistic regression. There are 3 main types of logistic regression. One is binary logistic regression, multinomial logistic regression, ordinal logistic regression. Now let's see each of them. Binary logistic regression. This is used when the dependent variable has only 2 possible outcomes, and this is the common type of logistic regression. The examples are, we can categorize results as spam versus not spam. Similarly, pass versus fail, or yes versus no. Multinomial logistic regression. This is used when the dependent variable has more than 2 categories, unordered. The examples are the predicting the types of vegetable like broccoli, beans, eggplant, and so on. And another is predicting customers' preferred payment method, either cash or card or online. Ordinal logistic regression. This is used when the dependent variable has 3 or more categories with order. It takes order of categories into account. The examples are customer satisfaction. We can categorize as poor, average, good or excellent. Similarly, we can categorize hotels ratings as 1 star, 2 stars, 3 stars, 4 stars or 5 stars. Advantages. The advantages of logistic regression are it's good for binary classification, it's simple and easy to understand, it is fast and efficient, it provides probabilities not just class labels. Disadvantages. The disadvantages of logistic regression are it's not good for very complex data. Similarly, it is difficult with multi-class problems and it only works well when the relationship is roughly linear in the log odds. Applications. Logistic regression is widely used in medical field, banking, marketing, email filtering, fraud detection, weather forecast, remote sensing, insurance company, and so on. Okay, that's all for logistic regression. So today we have learned that logistic regression is used for classification and it uses sigmoid function to output probabilities, and it is very simple and widely used in real world applications. Today we are learning one of the most fundamental algorithms in machine learning, that is the decision tree. Now let's start our video. So what is decision tree? It's a supervised machine learning algorithm and it is a flow chart like model which makes decision step by step, and at the end of each path there is either a decision or a prediction. Let's see its example. Imagine a scenario where we are deciding whether to play outside or not. So first we might ask, is it raining? If yes, then stay inside. If no, then we may check another condition like temperature. So, if temperature is greater than 24 degrees, then play outside. Otherwise, stay inside. Therefore, this is how a decision tree works, by asking questions and splitting the data step by step. Decision tree structure. A decision tree is like a flow chart used to make decisions. There are different parts to it. We have root node. This is the topmost node of the tree and is the starting point, and it represents entire dataset. Decision node. These are the decision points inside the tree, and each node tests a condition such as age is greater than 20 or study hours is greater than 40, something like that. And based on the test, the data is split into different branches. Branches. A branch represents the outcome of test. It connects one node to another node. Leaf nodes. They are the endpoints of the tree, and a leaf node gives the final prediction or a decision. How does a decision tree work? The first step is to define the problem. For example, we want to predict will a person buy a car or not. We have data such as income level and credit score. Let's start with the root node. At first, the algorithm looks all the features and decide which one to split. Suppose if the best feature is income level, then root node equals to income level. Then let's create branches from the root node. From the income level feature, we can branch into high income, low income and medium income. If high, then a person will buy a car. If there is a low income, then he or she will not buy a car. But if the income is in the medium range, then we need to check another factor, that is credit score. It will be like a person will buy a car if there is a medium income and good credit score. Otherwise, he or she cannot buy a car. At the end of every branch, we get a final decision in leaf node. High income, yes to buy a car. Low income, no. Medium income plus good credit, then yes. And medium income plus bad credit, then the result is no. So this is how a decision tree works like. Let's see the tree with a real example. We have data such as a person with income equals to medium and credit score good. Then the tree will check if income is medium, then go to the credit score branch. If the credit is good, then the final decision, that is to buy a car. Therefore, the tree keeps splitting the data step by step until it reaches a clear decision. Entropy. It measures uncertainty and randomness in the data. The higher the entropy, more the information content. And the formula to calculate entropy is like this. Here P1 and P2 are the probabilities of classes When a dataset has all the same outcomes or belong to one class, then the entropy is 0, which means pure. That is, there is no uncertainty left in predicting the outcome. Similarly, if the outcomes are evenly splitted or equal number of yes and no, then the entropy is 1 or high because we don't know which outcome to predict as it is uncertain. The example is like tossing a coin. We can get probability of tails like 0.5 or the probability of heads 0.5, and then if we calculate entropy in this case, it is equal to 1. Hence, there is a maximum uncertainty as we cannot predict when it is head or tail. But if we have 90% head or 10% tails, then at that time the entropy calculation equals to 0.469, which means it is less uncertain to predict than the ordinary case. Information gain. Information gain let us know how much entropy is reduced after a split. The formula to calculate information gain is like this. Here, S is the original dataset, A is the feature, SV is the subset after splitting. So we calculate information gain for each feature, and to split we pick the feature with the highest information gain. Let's see an example of information gain. Suppose we have 10 students and 6 are passed and 4 are failed. Therefore, entropy before the split can be calculated like this, and it is 0.97. Now, if we split on study hours, we can group like Group 1 and Group 2. Group 1 is a student who study more than 5 hours, and in that group we have 5 pass and 1 fail, and its entropy calculation is 0.65. Similarly, Group 2 has the entropy as 0.81, and the weighted entropy after the split is 0.71. Therefore, the information gain is 0.97 minus 0.71, that is 0.26. So this tells us study hours is a good feature to split on. Let's see another example. Our dataset is to play tennis based on the weather. So this is our data. We have total samples 8, and we have here 5 yes and 3 no. And if we calculate the entropy, then entropy equals to 0.95. Now if we split by the weather, for sunny we have 3 samples, 2 no and 1 yes. Therefore the entropy will be 0.92. And for cloudy there are 2 samples, both are S, then the entropy is 0. And for rain there are 3 samples, 2 S and 1 no, and the entropy calculation is 0.92. So if we calculate the total entropy, then it is equal to 0.69. Therefore, the information gain is 0.95 minus 0.69, that is 0.26. Hence, the weather is a good splitting feature. Advantages. It works for the classification and regression. It's easy to understand and visualize. It handles both categorical and numerical data. Disadvantages. It is biased towards features with more labels such as ID numbers. Unstable. That means small changes can alter tree drastically. In this video, I will explain the decision tree example in Python code. So let's start our video. Now let's practice decision tree in Python code. First, let's import the libraries. So step 1 is import libraries from sklearn.tree import decision tree classifier, and then plot tree. So this decision tree classifier, it builds the decision tree model, and plot tree, it draws the tree so we can visualize it. Next is import matplotlib.pyplot as plt. So this will show the image. The step 2 is creating a small data set, and let's say features are like weather, and then sunny equals to 0 and rainy equals to 1. And let's say another feature is wind, and if it is weak it is 0, and if it is strong equals to 1. So x equals to 0, 0. So this means sunny and then weak. Similarly 0, 1, it means sunny, strong. Another is 1, 0, and then it means rainy and weak. Next 1, 1 is rainy and then strong. Another is, let's say our target is to play tennis, and here yes, let's say s equals to 1 and no equals to 0, that is equals like sunny is equals to like yes and 1. Similarly rainy is equals to like no, it means 0. Y equals to 1, 1, 0, 0. So x is our input feature. Here each row is a scenario like weather and wind, where y is the output level, whether to play tennis or not. And here we want the sunny, that is to play, which is S, and rainy, that is don't play, which is no. Then step 3 is create and train the model. Model equals to decision tree classifier, and then criterion equals to entropy. So this criterion equals to entropy will tell the model to use the information gain to decide the splits. Next is model dot fit and then x, y. So this will train the tree using our data, so it will learn the pattern. And the tree now learns the rule sun equals to yes and rain equals to no. The step 4 is to make a prediction. And then prediction equals to model dot predict and then 0, 0. Let's take this one, and this means sunny and weak, right? And print and then we'll play tennis. We'll ask, we'll play tennis, and then question mark, and then sorry, if yes, if prediction 0 equals to 1, else no. Okay, so we'll ask the model if weather equals to sunny and wind equals to weak, that is 0 0, can we play the tennis, like that. Then it predicts yes, since sunny equals to play. We'll see in the result later on. Now step 5 is to visualize. Plot dot figure, and then figure size equals to 5 comma let's say 4, and so this will draw the decision tree. Another is to plot underscore tree, and then model comma feature underscore names, and then I will write here weather and wind, and close this, and then comma class names equals to no, yes, and I will close this one, and field equals to true. Okay, so this feature names will label the node with the weather and wind, and class underscore names will label the result as yes or no, and then field equals to true will color the boxes to show the decision. Then plot dot show, so this will display the image. Now let's run this. Yes. So here the root node is a weather, and the leaf nodes are the final prediction, that is yes or no, and wind feature is not needed. Therefore, this is how we first made a tiny data set, that is weather and wind, then trained a decision tree, and we tested it. Finally, we drew the tree to see how the decision was made, and it is yes to sunny and weak. Now let's see if it is like 1 comma 1. Let's run this. So it is also no, because the 1 1 means like rainy and strong wind. We are at day 10 of our machine learning series. In this video, we are going to learn about random forest, which is one of the most popular machine learning algorithm. So let's start our video. So what is random forest? Random forest is a supervised machine learning algorithm. It can be used for classification and regression problems in machine learning. Random forests are ensemble learning method as they are built from multiple decision trees. Random forests help to improve accuracy and reduce error as compared to single decision tree. That means the greater the number of the tree, the more accurate and the stronger the model will become. So this is how a single decision tree looks like. However, the random forest looks like this. It's the combination of multiple decision trees. Why random forest? Because it has higher accuracy. The final prediction is usually more accurate as the prediction comes from different trees. It reduces overfitting. First, let me explain what is overfitting. Suppose we have a single decision tree which has every detail of training data and it performs well on this data. However, it may fail on the new data. This problem is called overfitting. Random forest reduces overfitting because it has many trees and each tree is trained on different random data set and its features. When it is combined, then the error or the noise cancel out, making our model work better. Random forest works for both, whether it is classification problem like predicting yes or no decisions or regression problem like predicting continuous numbers. Next is feature importance. Random forest tells which variables are more important in our dataset. And the last is it handles missing data and noise. Random forest handles missing data and noise. In some cases, trees might have incomplete data, however the forest as a whole still makes a good prediction. History of random forest. In 1996, Leo Bremen introduced bragging, that is bootstrap aggregating, to improve decision trees. In 2001, Bremen introduced random forest, combining bagging with random feature selection for better accuracy. How random forest works. So this is the structure of random forest. Now let's see step by step. First is to create multiple decision trees. That is, each tree is trained on bootstrapping. That means randomly selecting samples with replacement to create subset. That's why each tree gets different datasets like class 1 and class 2. Another step is to select random feature. At each split, only a subset of features is considered, and this step prevents all the trees from being identical and it reduces the correlation. Another step is to build trees and make prediction. So grow each tree fully so that each tree independently makes its predictions. And finally combine all the predictions. So for classification problem we choose the majority part, whereas for regression problem we take the average of different trees outputs. That means from this figure we have final predictions like class 1 and class 2, but here is the majority is class 2. So for instance, if it is a classification problem, then our final prediction is class 2. Hence this is how the decision tree works. Now let's see the limitations of random forest. First is training time. The training time of random forest can be slow for huge datasets or large number of trees. Next is bias with certain features. It can be biased with certain features such as trees with so many categories, as well as highly correlated features can sometimes dominate the splits. The third is complexity and memory. As compared to a single decision tree, random forest has large memory uses and they are complex, so it has a lower training and prediction period. Overfitting possibility. With noisy data and very complex trees, it can still overfit slightly. Less interpretable. It is difficult to visualize and explain the random forest as compared to a single decision tree. Okay, that's all for random forest tutorial. We understand that random forest is a powerful and widely used in machine learning. It reduces overfitting and works for both classification and regression problem. In the next episode, I will explain the random forest with its example in Python. In the earlier video, we learned what is random forest in machine learning. In this video, we are going to see the Python implementation of the random forest. So let's start our video. The first step is to import the libraries. So step 1 is to import libraries from sklearn.ensemble. Import random forest classifier. Random forest classifier. So this line will import the random forest model class. And next is from sklearn.model and then selection import train test and then split. So this will split the data into training set and the testing data set. Next we have is from sklearn dot metrics import accuracy score. So this will import a function to measure the accuracy, like how many predictions the model got right or not. Next is import pandas as PD. So this library will create and manipulate the tabular data. Now the next step is to create the dataset. We are going to write a code to check whether a person can buy a car or not based on the parameters like age or the salary. So let's create the dataset. The step 2 is to creating a data set. So our data set equals to, we'll create here a dictionary. That's why, like age, one of the parameter is age, and then I'll give the age like 20, 21, 24, 27, 31, 34, 41, 44 and 51, 56, 62, 65. So these are the ages, and another is salary. And then I will write here 22,000, 25,000, 30,000, 35,000, 40,000, 45,000, 50,000, 55,000, 60,000, and then 70,000, 75,000. Let me check. 1 2 3 4 5 6 7 8 9 10 11 12 3 3 6 9 65. Okay, here 65. One data is missing, that's why. Okay, next is our is to buy car, and then like 0 or the 1. 0 means no, and then 1 means yes. So let's write here 1 1 1 1 1, and then 1 1. Okay, this is it. So here yes means 1, and then no means 0. So let's close this, and then so this will create a Python dictionary containing age, salary, and the by columns. Another is df equals to pd dot data frame and then data set. So this will convert the dictionary into pandas table. Next is x equals to df and then and we have is, I'm defining x and the y, and here salary and y equals to df by car, right? So x has the input features like age and salary that the model will use to learn, and y is the target vector that we want to predict. If it is a 0, then it is yes. If it is if it is 1, then it is yes. If it is 0, then it is no. Next step is to split the data set into training and the testing data. So step 3 equals to splitting data set into training training and testing data. So let's give here x train comma x test comma y train comma y test equals to train, like the earlier were, split, and then x comma y comma, and I will keep the test size equals to 0.3 comma, and then random state, so equals to 42. Okay, let me explain this. This train, test and split, it will split the data into training and the testing data set, and then this test size equals to 0.3 means 30% of the data is used for the test data, whereas 70% of the data is for training data. And here another we have is random state 42. That means if we set the random state like example 42, then we are fixing the randomness so that the results are always reproducible. That means the same trees, same split and the same accuracy. But if we do not set the random state, every time we run the code we might get the different results. So due to like different split, different forest and slightly different accuracy. Overall it returns the 4 objects, that is x train, x test, y train and y test. The next step is to create the random forest model. So step 4 is to creating random forest model. Now model equals to random forest classifier, and then I will give n estimators equals to 10, and then random state equals to 42. So this will create the random forest object. Here n estimators equals to 10 means build 10 trees in the forest, and then random state equals to 42. It will fix the randomness as I explained earlier. So this is how we create the random forest model. Now let's move to the training. Step 5. Okay, dash training the model. Model dot fit equals to x train, x underscore train, and then y train. So now this line will train the random forest for all the trees, and once the model is trained it will learn the pattern from the training data, and the next is the prediction. So step 6 equals to like making predictions. Y prediction equals to model dot predict and then x test. So this model dot predict uses the trained forest to predict the level for new x test data, and y pred is an array of the predicted levels, that is 0 or the 1 for the test data. Then we will check the accuracy. So step 7 is checking the accuracy. Print accuracy is and then I'll give the accuracy score, and then I will give input as test and y will spread, right? So this combine the predicted level y pred to the true levels, that is y test, and print the accuracy. And another step is to check for the new data. Let's say steps 8, and then is like predicting for a new data. Let's say is equals to 31, 35,000, and then closing the parenthesis. New data equals to 31, 35,000. Okay, another is I will write prediction equals to model dot predict and then new data. Okay, and print then will he/she buy a car? Yes, if prediction 0 is 1, else no. And then close this. So here new data is to create the new sample, and model.predict, it will predict whether this person will buy a car or not, and finally print the result is yes or no. Now let's run and see this code. Here is error. I don't need this. Yeah, again there is error. Here is also. So this is the result. Here the accuracy is 1, that means 100%, and will he or she buy a car? The result is no. Here we have given 31 A's and then the salary is 35,000. So if I do like here like 35, and then salary is also a little bit more, like 60,000, then let's see. So the answer is yes. So this is the example of the random forest in Python. I hope you like this. In today's video, we are going to learn about one of the simplest algorithms in machine learning, that is k-nearest neighbor or KNN. So without further ado, let's get started. So what is k-nearest neighbor or KNN? KNN is a supervised machine learning algorithm used for classification and regression. It works by finding the k closest data points to new data point based on a distance metric like Euclidean distance. It then makes predictions based on majority vote for classification or average for regression. It is also called as a lazy learner because KNN does not build a model during training process. It just stores the data and makes prediction when it is required. Let's see an example of KNN. Suppose we have clusters of data like this. Here are two types of data, that are blue circles and orange diamonds, which are labeled as class 1 and class 2. Now, if we have a new data like this, and we have to find out in which class it belongs to. For that, we have to find its nearest neighbor as shown in the figure. To calculate the nearest neighbor, we have different types of distance metrics, which I will discuss later on. So these are the nearest neighbors of our data. After that, we have to decide the value of the k. If it is 3 like this, then the majority will decide. Here, majority is 2, which are of class 1. Therefore, our data also belongs to class 1, that is blue circle. Hence, this is the basic concept of KNN. What is k in KNN? In KNN, k is the number of nearest neighbor the algorithm considers while making a prediction. Let's see an example. If we want to predict whether a new student plays basketball or tennis based on his or her height and weight, so if k equals to 1, we look at the closest student only. And if that student plays basketball, then it will predict basketball. But if k equals to 3, we look at the 3 closest students. If 2 students play basketball and 1 plays tennis, then the majority is basketball. Therefore, we predict basketball. Hence, the value of the k can be adjusted according to the type of our data, and choosing the right k is important. The small k is more sensitive to noise and can overfit, whereas the large k gives smoother decision, but it may lead to underfit. There are different distance metrics for different types of data. The most used formula in KNN is the Euclidean distance. Similarly, we have Manhattan distance, Minkowski distance. The most used formula in KNN is the Euclidean distance, and the choice of the distance metrics affect the KNN performance. The formula to calculate Euclidean distance is like this, and using this formula we calculate nearest neighbors. KNN algorithm. The first is the collection of data, and then choose the number of neighbors, that is k. The third is calculate the distance between new point and all existing data points. And the fourth is sort all the data points based on distance. And then choose the k nearest neighbors. Choose the majority class among neighbors if it is classification. If it is regression, take the average of neighbors value. So this is the KNN algorithm. Mathematical explanation. Now let's see KNN with some real example. Suppose we want to predict whether a person will buy ice cream or not based on temperature and humidity. Here is our data. One is temperature and the other parameter is humidity. And in buy ice cream column, if it is 1, then it is yes. That means he or she can buy ice cream. If it is 0, then it's no. Now we want to predict for the condition if temperature equals to 24 and humidity equals to 57. First, let's calculate Euclidean distances. For example, when the temperature is 40 and humidity is 70, we consider this as x2 and y2. And our x1 and y1 are 24 and 57. Then let's use the Euclidean distance formula and get the result as 20.65. In the same way, we calculate for all data and get like 13.60, 3.16 and 7.61. Now, if k equals to 3, then we choose the nearest distances as 3.16, 7.61 and 13.60. Here two values has no and one is for yes. That's why our prediction is also no, because majority vote goes for no. Therefore, a person cannot have ice cream on the condition where temperature is 24 and humidity is 57. So this is how we can make prediction in KNN. Advantages. It is very simple and easy to implement. It is versatile as it works with classification and regression. There is no training required because it is called lazy learner. It works well with small data sets. Disadvantages. Cost of dimensionality, that means it doesn't work with high dimensional data. Choosing the value of k can be tricky. Slow with large data sets as it computes distance to all points. It can be prone to overfitting. Real-life applications of KNN. It can be used for recommendation system for suggesting products by history of other users' purchase. Another is customer segmentation. We can group customers and analyze their shopping behaviors. It can be used for medical diagnosis for identifying different diseases based on various health measurements. Another is KNN can be used for spam detection. If there is a new email, then it is compared with existing spam and non-spam emails. After that, it decides whether it is a spam email or not. So these are some of the applications of KNN. There are so many other use cases of KNN in real life. Okay, that's it for KNN. We learned that KNN depend on its neighbors. That is why choosing the value of the K is really important. It is great for smaller datasets. In the next video, I will come with its implementation in Python. Hello and welcome back to the channel. In the earlier video, we learned about KNN or K nearest neighbor. In this video, we are going to practice KNN in Python code. So let's get started. The first step is to import the libraries. So let's import libraries. Step 1 is importing libraries from sklearn.neighbors import kneighbors classifier. Kneighbors classifier is the KNN algorithm for scikit-learn. Another is from sklearn.model selection import train test split. So this will split the data into training set and the testing set. Next we have is from sklearn.metrics import accuracy score. So this will measures how well the model predicts. And last is import pandas is PD. This will help to create and manage the dataset in the table format. Step 2 is creating a dataset. Step 2 creating a data set. Data equals to this one, and then our first input is temperature. So in this example, we are going to predict whether a person will buy an ice cream based on the temperature and the humidity, which I have explained in my earlier video. So let's keep the input for that condition. So temperature is one of the input, and here I will give 30, 25, 20, 22, 28, 35, and then 40, and comma, and next is like humidity, and 70, and then 65, and then 60, 50. These are random data. And 5, 80, 85, and then close. And next is the buy ice cream. Ice cream 1 1 0 0 1 1 1. Okay, and finally I will close this braces. So here we make a data set with temperature, humidity, and whether a person buy ice cream or not. Like 1 means yes and 0 means no. df equals to pd dot data frame and then data. So df is a table of this data. X equals to df and then temperature, another is humidity, and y equals to df and then buy ice cream. So here x is input, that is temperature and humidity, and y is the output, that is buy ice cream or not. Next step is to split the training and the testing dataset. So step 3 is train and the test split. Okay, then x train and then x test and then y train y test equals to train test split and then x comma y comma test size equals to, I will give 0.3 and then random state equals to 42. Okay, so this will split the data into 30% for testing set and 70% for training the model. Next is step 4 is for creating the KNN model. So model equals to k neighbors classifier and then n underscore neighbor equals to 3. So this creates a KNN model with k equals to 3. This will source for the 3 nearest neighbors to decide. Another is modeled dot fit and then x train comma y train. So this will train the model using the training data. Step 5 is prediction. Now let's do the prediction. So y pred equals to model dot predict and then we'll give the x test, then we will print accuracy comma accuracy underscore score and then y test comma y pred. Okay, so this will predict the labels for the test set and the first one, and the accuracy score, you will compare the prediction with actual answers and this will print the model accuracy. Step 6 predict for new case. So prediction equals to model dot predict, and then I will give the input like 24 temperature and the humidity is 57. Okay, then print will buy ice cream, question mark, comma, yes, and then if prediction 0 equals to 1, else no. So this will predict for a new input, that is temperature equals to 24 and humidity is 57. Then if the model is output, then a person will buy ice cream. If it is 0, then a person won't buy ice cream. Now let's run and see. See, we get the accuracy score at 0.66, and in the will buy ice cream, the answer is no. Therefore, the result is 0. That means a person will not buy ice cream at the temperature 24 and humidity 57. Now, if I change the data into like temperature 31 and then humidity is like 71, let's run. So it is yes in this condition. Okay, that's all for today. We have learned machine learning topics like regression, decision trees, random forest, KNN, and so on. I hope you like this video. This is the part 1 of machine learning series. I will definitely come with part 2 very soon. If you think this video is really helpful, please do not forget to like, share and subscribe my channel, and comment down if you want me to cover new topics. Thank you for watching. I will see you in the next episode.